Here, we follow the systematic analysis table to identify the given salt. 1. Preliminary examination. A. Color. The color of the given sample is white. Therefore, the inference is copper, ferrous, and manganese cations are absent. Now, the next test is physical state. The physical state of the given sample is crystalline. Now, the next test in the preliminary examination is solubility. Now, the next test in the preliminary examination is solubility. We add small amount of the given salt to the test tube containing water. We observe that the given salt is soluble in cold water. Action of heat. A small amount of the given salt is taken in a dry and clean test tube and it is gently heated with the help of a non-luminous flame of the Bunsen burner. The color of the salt is yellow and in cold conditions it is white in color. Therefore, it may be a zinc salt. Next, we move on to identification of anion. The first test is action of diluted HCl. Take a small amount of the given salt in a clean and dry test tube and then add few drops of diluted HCl. No gas is evolved or no characteristic observation. Therefore, we can infer that carbonate anion is absent. Thus, carbonate is removed from the list of possibilities. Now, we move on to the next step, that is action of concentrated sulfuric acid in cold condition. Take a small amount of the given salt in a clean and dry test tube and then add few drops of concentrated sulfuric acid along the inner walls of the test tube. No gas is evolved or no characteristic observation when concentrated sulfuric acid is added. Therefore, we can infer that chloride and bromide ions are absent. Therefore, we eliminate chloride and bromide ions from the list of possibilities. The next test is action of concentrated sulfuric acid in hot condition. In this test, a small amount of given salt is taken in a clean and dry test tube. Concentrated sulfuric acid is added and then it is gently heated. As we have added concentrated sulfuric acid to the salt in the previous test, we now directly heat this mixture with the help of Bunsen burner. No gas is evolved in the hot condition too. Therefore, nitrate is also absent. Therefore, we eliminate nitrate from the list of possibilities. Now, the possibility is sulfate ion. The next test is action of barium chloride solution. In this test, we add barium chloride solution to the salt solution. A white precipitate is formed. Therefore, we can infer that the anion present may be sulfate. Now, we perform the confirmatory test for sulfate ion. To the previous test tube, when we add concentrated HCl, the precipitate is insoluble. This confirms the presence of sulfate ion. This confirms the presence of sulfate ion. Therefore, the anion in the given sample is sulfate. Next, we identify the cation present in the given salt. Now, let us perform the group separation test on the given sample. The first group test action of diluted HCl. To the salt solution, we add diluted HCl. No precipitate is formed or white precipitate corresponding to the presence of lead is not formed. Therefore, we infer that first group cation, that is lead, is absent. Therefore, we eliminate the first group cation lead from the possibilities. Now, we test the sample for the presence of second group cation copper. Salt solution plus diluted HCl plus hydrogen sulfide gas. To the previous test tube, we add hydrogen sulfide gas. No precipitate is formed. Therefore, we infer that second group cation, copper, is absent. Therefore, we eliminate second group cation, copper, from the list. The next test is third group test. Salt solution plus ammonium chloride plus ammonium hydroxide solution. To the salt solution, we add ammonium chloride and then we add ammonium hydroxide solution. White gelatinous precipitate or dirty green precipitate is not formed. We can infer that third group cations are absent. Thus, we eliminate third group cations, aluminium, ferrous, from the list. Now, fourth group test. Salt solution plus ammonium chloride plus ammonium hydroxide solution plus hydrogen sulfide gas. To the previous test tube, we add hydrogen sulfide gas. We observe that a dirty white precipitate is formed. Therefore, we can infer that it may be a fourth group cation, that is zinc ion. We perform the confirmation test for zinc cation. Salt solution plus sodium hydroxide solution. To the original salt solution, we add sodium hydroxide solution. We observe that a white precipitate is formed. Now, when we add excess of sodium hydroxide solution to the test tube, we observe that the given precipitate is soluble. This confirms the presence of zinc cation in the given salt. Thus, zinc is confirmed. Thus, the given salt contains zinc cation and sulfate anion. Therefore, the final report of the salt is zinc sulfate.